because they have less energy after they bonded. Two pairs of electrons are shared between two oxygen atoms, forming double bond. Triple covalent bond in nitrogen. Three pairs of electrons are shared between nitrogen, forming triple bond. Covalent bond in ammonia, NH3. These are bond pairs. And these are lone pairs. Lone pairs are unshared pair, means they do not take part in bond formation. Limitations of Lewis Langmuir concept. How the atoms are held together in molecules like hydrogen and chlorine, in which there are no ions and hence there are no electrostatic forces of attraction. Second, the shapes of molecule containing covalent bonds. Third, the release of energy during the formation of a covalent bond. Difference between ionic and covalent. Ionic, metal, non-metal. Second, total transfer of electron. Third, high melting and boiling point. But in covalent they are non-metals. They are formed by the sharing of electrons. Low melting and room temperature boiling points. They are solids at room temperature, hard, brittle, inorganic compounds. They are strong bonds. Covalent bond, liquids and gases at room temperature, relatively soft and weak. What is coordinate bond? It is also called a dative bond. A covalent bond is formed by two atoms sharing a pair of electrons. Covalent bonds, they are formed by the sharing of electron pair. The atoms are held together because the electron pair is attracted by both of the nuclei. A coordinate bond, also called a dative covalent bond, is a covalent bond in which both electrons come from the same atom. In coordinate bond, it is also called a dative covalent bond. In this, both electrons, they come from the same atom. Ammonia, it has a nitrogen, it has a one lone pair. Ammonium ion is formed. Ammonia and BF3 molecule, both electrons come from the same atom and the dative bond. This arrow shows the dative bond. So, this bond is formed. ammonia, this is a normal covalent bond. Each atom supplies an electron. It is called normal covalent bond. But in ammonium ions, it is a coordinate covalent bond. The pair of electron come from the same atom. Characteristics of coordinate compounds: they do not ionize in water. Their melting and boiling points are higher than ionic compounds. Third, since they are not ionized in aqueous solutions, therefore their aqueous solutions are poor conductor of electricity. Since they are not ionized in aqueous solutions, therefore their aqueous solutions are poor conductor of electricity. Fourth property, they are sparingly soluble in water, but most of them are soluble in organic solvents like benzene and ether. They show isomerism as coordinate bond is rigid and directional. Coordinate compounds are less volatile than covalent compounds due to the semi-polar nature of coordinate bond. Electron sea or electron gas theory. This theory was proposed by Lawrence in 1923. Properties. First is low ionization energies. Second, presence of vacant orbitals. Third, electrons in the valence shell are called valence electrons. Fourth, rest of the atoms are known as kernels and is positively charged. Electrons in the valence outermost shell, they are called valence electrons, and rest of them are called kernels and is positively charged. Each kernel is surrounded by number of valence electrons. Each kernel is surrounded by valence electrons. Valence electrons are mobile and move in electron sea from one place to other. Kernels are heavy and have little mobility. The movement of valence electrons in the electron sea model is just like gas molecules. This theory is called electron gas model. Each kernel is surrounded by valence electrons. Metallic bond. Metallic bonding is the bonding between atoms within the metals. It involves the sharing of free electrons among a lattice of metal atom. Metallic bonds may be compared to molten salts. The electrons and positive ions in the metal have a strong attractive force between them. The electrons and positive ions, they have a strong attractive force between them. Therefore, metals often have high melting and boiling point The principle is similar to that of ionic bonds. So, metallic bonding is the bonding between atoms within the metals. Metallic bond. Metals are made up of closely packed cations rather than neutral atoms. Valence electrons are mobile, sea of electron. Metallic bonds consist of attraction of free floating valence electrons for the positively charged metal ions. Metallic bonds are formed between atoms of metallic elements. Electron cloud around atom. They are good conductors at all states, lustrous, very high melting points. For example, sodium, iron, aluminium, cobalt. Metals form alloys. Metals do not combine with metal, they form alloys, which is a solution of a metal in a metal. They are steel. For example, steel, brass, bronze, and pewter. Metallic properties and structures. They are good conductors of electricity. Second, they can be drawn into wires, means ductile. Third, they can be hammered or forced into shapes, malleable, arranged in very compact and orderly patterns. Alloys are the mixture of two or more elements, at least one of which is a metal. Properties of metals. Metals are solid at room temperature with the exception of mercury and gallium, which are liquids at room temperature. Luster. Metals have the quality of reflecting light from its surface and can be polished. Metals have the ability to withstand hammering and can be made into thin sheets. They are known as foils. Ductile. Metals can be drawn into wires. All metals are hard except sodium and potassium, which are soft. Valency. Metals have 1, 2, 3 electrons in the outermost shell of their atoms. Hydrogen bonding. Hydrogen bonding differs from other uses of the word bond, since it is a force of attraction between hydrogen atom in one molecule and a small atom of high electronegativity in another molecule. Because it is a force of attraction between hydrogen atom in one molecule and a small atom of high electronegativity in another molecule. That is, it is an intermolecular force, not an intermolecular force as in the common use of word bond. Valence bond theory. to rationalize how the shapes of atomic orbitals are transferred into the orbitals occupied in the covalently bonded species, we need the help of two bonding theories. One is valence bond theory and second is molecular orbital theory. VB theory. The theory, it describes the placement of electrons into the bonding orbitals located around the individual atoms from which they are originated. MO theory, all electrons from atoms involved into the molecular orbitals spread out over the entire species. This theory works well for excited species and molecules like oxygen. Okay, thank you.